Hello everyone, welcome to TechnoGate. In today's class, we are discussing about 8051 instruction set. Okay, so here the first one is data transfer instructions. Data transfer instructions. So this we will learn in this today's video. Okay, data transfer instructions. So what we will learn in this video, we will learn about 8051 instruction set and what is first one, data transfer instructions. Okay, and also we have other instructions, arithmetic instructions, next logical instructions, next branch instructions, next Boolean variable manipulation instructions. Okay, Boolean variable manipulation instructions. So like this we have so many categories. In the 8051 instruction set, we have so many categories. First one is what? Data transfer. So this data transfer instructions we will learn in this video. In the coming videos, we will learn about arithmetic instructions, logical instructions, branch instructions, and Boolean variable instructions. Okay. So instructions are very important in 8051. So mainly you have to concentrate on the instruction part. Okay. Now we will start our class. Today's class. What is today's class? Data transfer instructions. Data transfer instructions. Okay. So first one is what? Move a comma hash data. So if you want to understand this topic, then compulsory you have to see the addressing modes video. Okay. So first of all, you see the addressing mode video. Okay. After seeing that addressing mode video, then you open this topic. So if you directly come to this topic, you cannot understand. So what I am telling all of you. So before opening this video, first you go to the addressing modes video, 8051 addressing modes video. So complete that video. After that you come to this video. Okay. Then you can understand clearly what I am telling. Okay. So move a comma hash data. So here what we are doing, the data is copied to register A. Data is copied to register A. What is A? Accumulator. Accumulator is a 8-bit register. So move a comma hash data means what? Data will be moved to register A. A is nothing but accumulator, 8-bit register. Next one is what? Move a comma Rn. Move a comma Rn. Okay. So what is Rn here? Rn means a register. It can be R0, R1, R2, R3, R4, R5, R6, R7. Total 8 registers are there. Okay. So here Rn means it can be any one of the 8 registers. Okay. So what I am telling here is Rn is nothing but a register. The register can be R0, R1, R2, R3, R4, R5, R6, R7. Total 8 registers. So you can use any 8. You can use any one of the 8 registers. Okay. So move a comma Rn. So what happens here? Data in Rn register. Data in Rn register is copied to register A. Is copied to register A. Okay. Data in Rn register is copied to register A. Okay. So see the points what I am writing on the board. What is first point? Move a comma hash data. Data is copied to register A. Move a comma Rn. Data in Rn register is copied to register A. Okay. And next third one. Move a comma director. Move a comma director. So what is direct here? Direct is nothing but address location. What is direct here? Direct is nothing but address location. Okay. So what I have written here? move a comma direct. So what do you mean by direct here? Direct is nothing but address location. In the address location, what is there? In the address location, data is there, and this data is copied to register A. This data is copied to register A. Okay. Move a comma direct. So what do you mean by direct here? Direct is nothing but address location. In the address location, what is there? Data is there. So that data will be copied to register A. Okay. So read this sentence. Direct means address location. Address location contains data, and that data is copied to register A. Okay. Next one. Move a comma at the rate of RA. Move a comma at the rate of RA. So what is this? Move a comma at the rate of RA. So what is RA here? RA means it can be R0 register, R1 register, R2, R3, R4, R5, R6, R7. Okay. RA means you can take any register. So move a comma at the rate of RA. So here what is at the rate? At the rate means what? At the rate means RA contains address location. RA contains address location. Okay. So what is at the rate? At the rate means that register. Okay. What is that register? It can be R0, R1, R5, R6, R7, any register. Okay. So at the rate RA means that register contains what? Address location. Okay. And what this address location contains? Address location contains data, and this data will be copied to register A. This data will be copied to register A. So once again I am repeating these points. Listen carefully. Move a comma hash data. Move a comma hash data. So data is copied to register A. Next one, move a comma Rn. So what is Rn here? Rn is a register. It can be any one of the 8 registers. What are the 8 registers? R0 to R7. So data in Rn register is copied to register A. And what is third one? Move a comma direct. What do you mean by direct here? Direct means address location. In the address location, what is there? Data is there. So that data will be copied to register A. Next one, move a comma at the rate of RI. So what do you mean by at the rate of RI? RI contains the address location. In the address location, what is there? Data is there. So that data is copied to register A. So here what we are doing is, we are copying the data into register A. Okay, first one, second one, third one, fourth one. So what we are doing is, we are copying the data. We are copying the data into register A. See here, data copied to register A. Data copied to register A. Data copied to register A. If you see the board carefully, the common point is what? Data copied to register A. That is the common point. Okay. So this is data transfer instructions. What we are discussing here, data transfer instructions. Okay. So you understood what we are doing in this 4. What we are doing in this 4 instructions? In this 4 instructions, we are moving the data into register A. What is A? Accumulator 8-bit register. And next one is what? Move Rn comma A. Move Rn comma A. Okay. So previously what you have seen previously move A comma Rn. Previously what you have seen? Move A comma Rn. And here what you have seen? Move A comma direct. Move A comma Rn. Move A comma direct. Move A comma at the rate of Rn. Okay. So listen carefully. Second one is what? Move A comma Rn. What is third one? Move A comma direct. What is fourth one? Move A comma at the rate of Rn. Now we are doing reverse. Okay. Reverse is what? Reverse means move Rn comma A. Next, move direct comma A. Move direct comma A. Next, move at the rate of Ra comma A. Okay. So previously what we have discussed, okay, that I am writing opposite. Okay. So what do you mean by opposite? Move Rn comma A, move direct comma A, move at the rate of Ra comma A. So what does it mean? Okay. So here what does it mean? data in A, data in register A, data in register A is copied to Rn register, is copied to Rn register. Okay. So move Rn comma A. What do you mean by that? Data in register A, data in register A is copied to Rn register. Okay. Next, move direct comma A. So what do you mean by that? Data in register A, data in register A is copied to address location, is copied to address location, copied to address location. Understood? So move direct comma A. So what do you mean by that instruction? Data in register A, data in register A is copied to address location. Whenever you see the director, whenever you see the direct word, what you have to understand? It means address location. Okay. So data in register A is copied to address location. Next one, move at the rate RA comma A. Same. Data in register A, data in register A is copied to address location. Both are same. Okay. Move direct comma A, move at the rate RA comma A. Okay. The working is same. What is that working? Whatever the data in register A, that will be copied to address location. So read carefully. Data in register A is copied to address location. Data in register A is copied to address location. So what I am telling is, in A some data is there. Okay. So that data we are moving to address location. Okay. So what is the difference? What is the difference between 6 and 7? In sixth one, address is directly specified. In sixth one, address is directly specified. Okay, directly specified. Address is directly specified, and the seventh one, address is indirectly specified. Address is indirectly specified. So that's the main difference. Working is same. What is that working? Whatever the data in register A, that will be moved to the address location. Sixth one is same, seventh one is same. Data in A will be moved to address location. Okay, but what is the difference? In sixth one, address is directly specified. In seventh one, address is indirectly specified. Okay, so that's the difference. And next one, push. Okay, push direct. And next ninth one, pop direct. Okay, push direct and pop direct. So what is this push and pop? What is this push and pop? So push means nothing but insert. So push is nothing but insert data into stack. What is push? Push is nothing but insert data into the stack. And what is pop? Pop is nothing but remove the data from the stack. Remove the data from the stack. So first of all, you have to understand what is push and pop. Push is nothing but insert data into the stack, and pop is nothing but remove data from the stack. And already you know what is stack. What is stack? Stack is nothing but memory element. Stack is nothing but memory element. And what is the principle? LIFO principle. LIFO principle. What is LIFO? Last in first order. LIFO means what? Last in first order. So what is stack? Stack is a memory element. What is the principle? LIFO. LIFO means what? Last in first order. And what are the operations? Push and pop. Push means what? Insert data into stack. And what is pop? Remove data from the stack. Insert data into the stack and remove data from the stack. Okay. So try to understand what is stack. Stack is memory element, and what is the principle? Principle is LIFO principle, last in first order. And how many operations are there? Two operations, push and pop. Okay. So here what I have written, push direct and pop direct. Okay. So here what happens is, four banks will be there. Four banks will be there in internal RAM. Okay. Four banks in internal RAM. What is the internal RAM size? Internal RAM size 128 bytes. Internal RAM size 128 bytes. Okay. So in internal RAM, how many banks are there? Four banks are there. What is the internal RAM size? 128 bytes. Okay. In the starting introduction, I told internal RAM size 128 bytes. Internal RAM size 4 KB, 4 I/O ports, 2 timers. Okay. So everything I told these points. Okay. So once watch to the basics of 8051. So what is the internal RAM size? 128 bytes. And how many banks are there? 4 banks are there in internal RAM. Okay. So bank 0, bank 0, bank 1, bank 2, bank 3. Okay. So bank 0 is the address range. Bank 0 address range 00207. So this is the address range of bank 1. What is the address range of bank 1? 00207. And bank 1 address range 082 0F. Bank 2 address range 102 17. Okay. And next bank 3 address range 182 1F. Okay. Bank 0 address range 00207, bank 1 address range 0820F, bank 2 address range 10217, and bank 3 address range 1821F. Okay. So total how many banks are there in the internal RAM? In the internal RAM, 4 banks are there, bank 0, bank 1, bank 2, bank 3. So address ranges are very important. 00207, 0820F, 10217. And 182 This is the complete address ranges of banks. Okay. Now what I am discussing previously, I am discussing about what? Push direct, pop direct. Okay. So we started from here actually. Push direct and pop direct. What is push? Insert data. What is pop? Delete the data from the stack. And already you know what is stack. Stack is the memory element. It works on the LIFO principle. Now coming to our main point here. Bank 1 is used for stack operations. Bank 1 is used for stack operations. Okay. Bank 1 is used for stack area. So how many banks you have? You have 4 banks. Bank 0, bank 1, bank 2, bank 3. So out of these 4 banks, which one you have to use? You have to use bank 1. You have to use bank 1 for the stack area. Okay, this is a very important point. Which one of the following banks is used for stack operations? What is the answer? Bank 1. Okay, what I am telling here is total 4 banks are there. Bank 1 we have to use for the stack operations, for the stack area. Okay. Now here what is push and what is pop, that we will discuss now. For example, push 12. Okay. Push 12. Okay, what is 12 here? 12 is the address location. 12 is address location. Okay, so what is 12 here? 12 is the address location. In this address location, what is there? Some data is there. Some data. 45. Okay. Push 12. What do you mean by 12? 12 is nothing but address location. In the address location, some data is there. What is that data? 45. So this 45, what happens is, this 45 will be stored in the stack. This 45 will be stored in stack. Understood? Push 12. Example I am giving. Example is what? Push 12. So 12 is what? 12 is address location. In the address location, what is there? Some data is there. What is that data? 45. So this 45 will be stored in the stack. Okay, so that's the point. And in what is the bank 1 address range? Bank 1 address range is 08 to 0F. So this 45 will be stored. This 45 will be stored in 08 address location. This 45 will be stored in 08 address location. So try to understand what I am telling. Okay, push. What I have written here? Push direct. Example what I am giving? Example is what? Push 12. What is 12? 12 is the address location. In the address location, what is there? Some data is there. What is the data? 45. So this 45 will be stored in stack. Okay, in stack where? Okay, what is the stack range? Stack range is 08 to 0F. Okay, so previously I told both banks are there. Bank 0, bank 1, bank 2, bank 3. Bank 1 is used for stack area. And what is the stack range? 08 to 0F. So finally what I am telling, this 45 is stored in the 08 address location. Okay, so you understood about the push direct. Push direct. So what do you mean by push direct? Example, push 12. 12 is the address location. In the address location, what is there? 45 data is there. This 45 will be stored in the stack. In the stack, which location? Okay. What are the stack locations? Stack locations are 08 to 0F. Okay. So this 45 will be stored in the 08 address location. Okay. So this is the point. 45 data will be stored in the 08 address location. So this is about the push operation. So whatever the data 45 is there, that 45 will be stored in the 08 address location. Why 08? Why? Because 08 to 0F is the address range for bank 1 and we are using bank 1 for the stack operations. Okay. So see the interlink. 12 address, in the 12 data 45, that 45 is stored in the 08 address location of stack. Okay, so this is how the push will work. Okay, and next pop. So what is pop? Pop direct, reverse operation. Pop direct. Okay, so previously what I told? 12 is the address location. The address location contains 45. That 45 is stored in the 08 address of the stack. So this is push. And now pop. So pop is quite opposite. Okay, push and pop are quite opposite. Push means insert and pop means delete. So here what happens now? Pop direct. Pop 12. Pop 12. Okay, so what happens here? In the 08 location, in the 08 address location, what is there? 45 is there. Okay, in the previous slide, I explained you 08 address location. What is there? 45 is there. Now this 45 will be deleted. This 45 will be deleted. Okay, from the stack. This 45 will be deleted from the stack. Okay, and this 45 will be stored here. This 45 will be stored in the 12 address location. Okay, so push and pop are quite opposite. So what I am telling is the push and pop are quite opposite. So previously what we have done, okay, so that is the quite opposite of pop. So what you are doing here, in the 08 address location 45 is there, so that 45 will be deleted from here and that will be stored in that 12 address location. Okay, so next XCH. Okay, XCH A comma RN. Okay, XCH is nothing but exchange. XCH means exchange. So for example, in A45 is there. In A45 is there. In Rn we have 41. In Rn we have 41. So what A contains? A contains 45. And what Rn contains? 41. Now this will be exchanged. Exchange means what? Exchange is what? A is 41 and Rn is 45. Okay. So we are simply exchanging. We are simply exchanging A and Rn. Okay. If you observe here, A contains 45, Rn contains 41. So what we are doing here? We are exchanging it. Now A is 41 and Rn is 45. So this is about XCH. So from where we started? We started from the move A comma hash data, move A comma Rn, move A comma direct, move A comma at the rate of Ra. Next move Rn comma A, move direct comma A, move at the rate of Ra comma A, push direct and pop direct. Okay. Next XCH. XCH. Okay. XCH by exchanging. Next one is move C A comma at the rate of A plus dptr, move X A comma at the rate of A plus dptr. Okay. So move C A comma at the rate of A plus dptr, move X A comma at the rate of A plus dptr. So what is dptr? Dptr is nothing but data pointer. dptr is nothing but data pointer 16-bit register. Okay. And dph is what? Higher byte register, 8-bit register, and dpl lower byte 8-bit register. So dpl plus dph is equal to dptr. dpl plus dph is equal to dptr. Okay. So what is dptr? dptr is data pointer. It's a 16-bit register. So dpl plus dph is equal to dptr. So what is dpl? Lower byte register. What is dph? Higher byte register. So this is lower byte 8-bit register. This is higher byte 8-bit register. If we combine these two, it dptr. Okay. So very important is dptr. In the microcontroller subject, dptr is very important. It's a 16-bit register. And what is there in dptr? In dptr we have lower byte part as well as we have the higher byte part. Okay. What is lower part? dpl, and what is higher part? dph. If we combine these two, that is dptr. Okay. So now what we are discussing here, move C A comma at the rate of A plus dptr, move X A comma at the rate of A plus dptr. Okay. So here what this instruction will do? For example, some data is there, some data in internal ROM is there. Okay. In microcontroller, what is there? In microcontroller we have the internal RAM and internal ROM. Okay, both are there. Internal RAM is 128 bytes, internal ROM 4 KB. Okay, I am talking about internal ROM. Data in internal ROM. Okay, so now I want to move this data. I want to copy this data into register A. Okay. So what I am discussing, some data is there in internal ROM. Now I want to copy this data into register A. So how you will do that? You will do by MOC instruction, by using the MOC mnemonic, by using the MOC. So whenever you want to move the data from the internal ROM into accumulator register, so what we have to use? You have to use MOC. don't use MOV. Okay, so previously I used MOV, but here we don't use MOV. What you have to use? You have to use MOC. Okay, so again I'm repeating this point. Data is there in the internal ROM. Data is there in the internal ROM. So that data I have to copy into register A. So what I want to do? I want to copy the data into register A. Okay. So how you will do that? By using the MOC instruction. Normally we know MOV, but here we are discussing what MOC and MOVX. Total three are there. What are the total three? MOV, MOVC, MOVX. So what I am telling you, you have the data in internal ROM. Okay. So that data you want to move into register A. So how you will do that? By using the MOC mnemonic. Okay. So compulsory you have to use MOC mnemonic if you want to copy the data from internal ROM into register A. And next this one, MOVX. MOVX. So what is DPTR? DPTR is the data pointer. It's a 16-bit register. We have a DPL and DPH. DPL means lower part, lower byte, and DPH is higher byte. Okay. So what is MOVX? Okay. Suppose external data in external ROM. Okay. Data in external memory. In external memory. Okay. So some data is there. Some data is there in the external memory. Okay. So what we have to do? So this data you have to copy the data into register A. Okay. So some data is there. In the external memory. So what you want to do? You want to copy this data into register A. So how you will do that? By using the MOVX. By using MOVX. So see the difference. When you have to use MOVC, when you have to use MOVX. So data in internal ROM that you want to copy into register A by using MOC. Next, data in external memory. Data in external memory that you want to copy into register A. So how you will do that? By using the MOVX. Okay. So see the difference between MOVC and MOVX. MOVC is related to internal ROM. MOVX is related to external memory. Okay. So finally what we are doing? We are moving the data into register A. Okay. So this is about MOVC and MOVX. And DPTR, what is this DPTR? Already I told you, data pointer, 16-bit register, DPH, DPL, okay, higher byte, lower byte. Now what DPTR contains? Okay, so DPTR contains, for example, I will take one example. 8,000. So 8,000 is the starting address of external memory. What is 8,000? 8,000 is the starting address of external memory. Okay. Now, and 8,001, 8,002. Okay. Like that, so on. 8,025. Next 8FFF. Okay. So this is the last address location. Last address of external memory. Last address of external memory. Okay. So what is the starting address? Starting address is 8,000. What is the next address? 8,001. What is the last address? 8FFF. Okay. Now suppose, what is the starting address? Starting address is 8,000. So DPTR contains 8,000. DPTR contains what? 8,000. Okay. So DPTR contains what? 8,000. What is 8,000? Starting address location. Okay. Suppose I want this data. I want this data to copy in register A. Data to copy in register A. Understood? See the scenario. 8000 is starting address. 8001 is the next address. 8FF is the last address. What DPTR contains? DPTR contains 8000. Now what I want to do? I want to come to this 8025. I want to come to this 8025. Some data is there here. That data I want to copy in register A. Okay. Come to 8025 address location. Here some data is there. That data what I want to do? I want to copy into register A. Okay. So now how you will do that? So for example, move x A comma at the rate of A plus DPTR. Okay. So previously I have written this statement, move x A comma at the rate of A plus DPTR. So what is DPTR? What is DPTR? DPTR means 8000. DPTR is 8000. Okay. And what is A 25? Okay. A is 25. DPTR 8000 and A is 25. Now what you will do? A plus DPTR. A plus DPTR. So 25 plus 8000. What is the answer? 8025. See the steps carefully. See the steps carefully. DPTR 8000, A is 25, A plus DPTR 25 plus 8000, 8025. Now we came to this location. 8025. Okay. Now at the rate of move x A comma at the rate of 8025. Okay. See the steps carefully from starting onwards. 8000 is starting address, 8001 is the next address, 8FF is the last address. Okay. Now what I want to do? I want to come to the 8025. In the 8025 some data is there. That data I want to copy in register A. Okay. So now what is DPTR? DPTR 8000. DPTR 8000 and A is what? 25. So 25 plus 8000. 8025. Now we came to that 8025. Okay. Move x A comma at the rate of 8025. Okay. Now what happens here? So this data, the data, okay, will be copied to register A. In the 8025 address location, some data will be there. 8025 is the address location. In that address location, data is there. So that data will be copied to register A. So this is how the instruction will work. Okay. So again we will revise these points. So starting what we discussed, move A comma hash data, move A comma RN, move A comma direct, move A comma at the rate of RI. Next one, move RN comma A, move direct comma A, move at the rate of RI comma A, push direct, pop direct, and next how many banks are there? We have 4 banks. And which bank is used for stack operations? Bank 1. And what is the bank 1 address range? 08 to 0F1. So what is stack? Memory element. What is the principal? LIFO principal. And next one is what? XCH. What is XCH? Exchange. And next one is MOVC, MOVX. So MOVC when we have to use? When we want to transfer the data from the internal ROM into register A. When we have to use MOVX, when we want to transfer the data from external memory into register A, then we have to use MOVX. And what is DPTR? A 16-bit register, which is a combination of DPH and DPN. Okay. So hope you understand this example. DPTR contains what? 8000. A contains what? 25. And what is 25 plus 8000? 8025. What is 8025? Address location. In the address location, what is there? Data is there. Okay. That data will be moved to register A. Okay. So all these are the data transfer instructions. So what I explained you, all these are the data transfer instructions. Okay. MOV explained, MOVC explained, MOVX explained, and XCH explained, push, pop. So all comes under data transfer instructions. In the coming class, we will discuss about arithmetic instructions, logical instructions, branching instructions and Boolean variable instructions. Okay, only in this video we will concentrate on data transfer instructions. Okay, so thank you for watching this video. Thank you.